morning, children. Today we are going to do the second part of the electrostatics. In this chapter, we will study about two important aspects of electrostatics. One is about electric potential, and the second part of the chapter we will study about capacitors. This term, electric potential, that is a familiar term to you, I think, because in class 10th you studied what is the meaning of electric potential and potential difference. How you defined electric potential in your class 10? It is defined as the work done to displace unit positive charge from infinity to a point in an electric field. See that definition once again? The work done to displace unit positive charge from infinity to a point in an electric field. What is the source of this electric field? In the previous chapter we studied the source of the electric field is a source charge. Suppose there is a source charge located at the origin. Around this charge there is electric field. In this electric field you are displacing unit positive charge. But you know, 1 coulomb charge, there is a bigger charge. So usually we are displacing small charge Q naught. And this Q naught is called, what is Q naught called? That is called test charge. Right? So we are displacing test charge from infinity to A. And what is, suppose the work done is W infinity to A to displace Q naught. Then according to your definition, electric potential at A is equal to work done to displace unit charge from infinity to A, meaning total work upon Q naught. What is Q naught? That is a test charge. Definitely it is a small charge. Similarly, what is the potential at B? It is W infinity B divided by Q naught. Now, suppose this is positive charge, is your source charge, and you can see in your diagram the position of A and B. Now you just tell which is bigger, VA or VB, which is greater. What is the idea? Which is greater? VB is greater. Why VB is greater? Because in VB there is more displacement, more repulsive force is there. Against the repulsive force you have to perform more displacement. Then only you can reach at B. Therefore work done is more in the case of B. Therefore VB is greater than VA. Now what is the SI unit of this potential? Very clear from this definition. Work done, that is joule, and charge coulomb. So joule per coulomb, that is the SI unit of electric potential, and joule per coulomb, that is called volt. And 1 joule by 1 coulomb, that is called 1 volt. So how will you define 1 volt? If the work done to displace 1 coulomb charge from infinity to a point is 1 joule, then the potential at that point is 1 volt. For example, suppose the potential at A is 3 volt and potential at B, which is correct, is it 3.5 volt or 2.8 volt? Smaller than 3 or more than 3, which is correct? It is more, so let it be 3.5 volt. Now what is this 0.5 volt stands for? What is this 0.5 volt? That is the work done to displace unit positive charge from A to B. So work done to displace unit positive charge from A to B, and that is called, you see very from here, potential at A is 3, potential at B is 3.5, so 3.5 minus 3, that is 0.5 volt, and that is called potential difference between A and B. So potential difference between A and B, PD, between A and B, and that is indicated by VAB. So VAB stands for potential difference between A and B. Now you see VA or VB, which is greater? VB is greater. So what is this potential difference? VB minus VA, and that is equal to WAB divided by Q. Now what is the unit of potential difference? That is also, you can see, joule upon coulomb or volt. So the unit for potential and potential difference both are same. That is a similarity. What is a dissimilarity? Potential is at a point and potential difference is between 2 points. Now you have to derive expression for electric potential at a point. But first we will derive potential difference between A and B. Then by using that definition, we will write an expression for potential at A. So it is a common derivation for potential as well as potential difference. So you can see the same diagram. Your Q, that is called source charge, and B is a point at a distance RB, R of B, and A is a point which is at a distance R of A. Actually, what is this R stands for? R stands for position vector. So you can write the position vector as R, and R is the magnitude of the position vector. And magnitude of the position vector, that is actually is equal to the distance. So here, that is why we marked here as RA and RB. Actually, RA stands for the position vector of the point A, and RB stands for position vector of the point B. Otherwise, in terms of distance also it is correct. RA and RB, there is a distance of the points A and B from the source charge. Now you take a point P, which is at a distance R from the source charge. Suppose Q0 charge is located at P. Q0 charge is located at P, and you are displacing this Q0 charge by a distance dr against this electric field. You see why this against the electric field? What is the direction of electric field at P? It is towards the right side. Why? Because plus charge is there. If you keep unity positive charge here, that will be repelled by the source charge. So the direction of electric field is towards right side, but your displacement is towards left side. So direction of displacement is opposite to the electric field, and the displacement is a small displacement. Therefore, the work done is small. So the small work done for the small displacement dr, you know, work done is equal to force dot displacement. So force vector dot displacement vector. And you know, dx or dr you can write small displacement. And A dot B is AB cos theta. So F dr cos theta. And what is the theta? You know, what is this F stands for? Because you know, E is equal to F by Q naught. That is what you studied in the first chapter. So instead of force, you can write Q naught E dr cos theta. So cos theta means that is the angle between two vectors. Which are the two vectors here? One is electric field vector, the other one is displacement vector. What is the angle between electric field and displacement vector? You can see that electric field is towards right side and displacement is towards left side. Both are in the opposite direction. Therefore, the angle between them is 180 degree. You know cos 180 degree. What is cos 180? Plus 1 or minus 1? It is minus 1. So cos 180 degree is minus 1. Therefore, here minus. So this is your dw. Now, what is your aim? You need potential difference between A and B. Potential difference between A and B, VA minus VB is equal to WAB by Q naught. So you got dw. From dw, how to reach W? The simple method is integration. So W is equal to integral dw. So integration Q naught EdR. Now what is a variable here? And what is a constant? You know, Q naught, that is a constant, because that is your test charge. And dr, that means R is a variable. But you know, in E, is there any R? E depends upon R. Is it directly proportional or inversely proportional? It is inversely proportional. And what is the formula for E? This is a definition. And E for a positive charge, unit charge. Positive charge is kq by r square. So instead of this E, you can write kq by r square. So your equation becomes minus q naught kq by r square. Now it is very clear, dr and r square. So r square is a variable. So how many constants are there? There are three constants. One is q naught, another one is q, another one is k, because dr is there. So you can take constants outside the integral sign. So WAB is equal to minus out, k, q, q naught out, and this 1 by r square you can write r raised to minus 2 dr integration. But integration, you need the limit. Initially, there is a charge. So, because you know WAB, so initially the charge is located at A. So, the initial value of R is R of A, and finally the charge is located at B. So, it is RB. Now, WAB is equal to minus K Q Q naught. What is the integration of x power n dx? So, the answer is x power n plus 1 by n plus 1. This is what is studied in your maths. So, similarly, what is integral r raised to minus 2 dr? We can apply the same formula here. So, it will become r raised to minus 2 plus 1. That is called minus 1. So, r raised to minus 1 by minus 1. That is integration. So, this integral becomes r raised to minus 1 by minus 1. Now, integration is over. Now, your limits are Ri and Rb. Now, this minus 1 and this minus. Together, it will become plus. So, your step is WAB is equal to KQ Q naught R minus 1, that is called 1 upon R, between the limit Ra and Rb. Now, what I will do? Upper limit minus lower limit. So, your answer will be WAB is equal to KQ Q naught upon upper limit 1 upon Rb minus lower limit 1 by Ra. Now, you see the definition. WAB is not called VAB. The potential difference between A and B means WAB, you have to divide with Q naught. Why you are dividing with Q naught? If you divide with Q naught, then only you will get the work done to displace unit positive charge. So that is why, if you divide left hand side and right side with Q naught, this is your expression. Now, what is this one stands for? According to this definition, this WAB by Q naught stands for potential difference between A and B. So, potential difference between A and B is equal to Q naught cancel. So, your answer is KQ into 1 by RB minus 1 by RA. And this is the final expression for potential difference between 2 points A and B. Now, based on this definition, you can move to potential also. Suppose you need electric potential at A. What is the meaning? Work done to displace the charge from infinity to A by Q naught. What is the potential at B? Work done to displace the charge from infinity to B by Q naught. Is it right? So, you use this idea in this equation. This is BAB or WAB by Q naught. So, WAB, if you need W infinity B, so B is B itself. Right? And instead of A, what is there? Infinity is there. So, you can replace that idea on this equation. So, what you are getting? Your answer is KQ bracket. Instead of 1 by RB, there is no change because here also B and here also B. So, it will be 1 by RB minus 1 by RA. What is your RA now? RA is infinity. So, it will be 1 by infinity. And what is 1 upon infinity? What is 1 upon infinity? It is 0. Right? So, this will become 0. So, potential at B means KQ by distance of B from the source charge. Right? What is potential at A? KQ by R of A. K into Q divided by distance of the point from the source charge. So, you can generalize. Potential at any point is equal to KQ by R. K, what is K stands for? K is called Coulomb constant. What is the Coulomb constant? What is the value of Coulomb constant in SI system? And if the medium is air, then your K is 1 by 4 pi epsilon naught. And its value, it is 9 into 10 power 9. That's the value. So, this is the expression for potential at a P. Now, you can sketch the graph between V and R. From this equation, it is very clear. V proportional 1 by R. If V is proportional to 1 by R, the graph between V and R, you take V here and R here. The graph V proportional 1 by R. Therefore, the graph is a curve. On the x-axis, it will touch the graph at where? Which point? we can see two things. If R is equal to 0 and R is equal to infinity, what is your potential? Can you tell? If R is equal to 0, your potential is infinity, 1 by 0 infinity. If R is equal to infinity, what is the value? It is 1 by infinity, that is 0. The potential is 0 at infinity, meaning graph is touching the x-axis at infinity and graph is touching the y-axis also at infinity. So this graph shows the variation of V with respect to R. What is R? Distance of the point from the charge. If the distance increases, it is very clear from the equation, potential also increases. In 2019 CBSE question paper, there is a question. There is a source charge Q and there are 2 points A and B. So the question is, if Q is positive, VA minus VB, is it positive or negative? This was the question. Can you tell the answer in this case? If this is a positive charge, the work done to displace 1 coulomb charge from infinity to B, infinity to A, which is more? The work done to displace the charge from infinity to A is more, right? So which is more? VA is more. So VA greater than VB. Therefore, VA minus VB is positive. See the difference. But if it is a minus charge, that's opposite. VA is smaller than VB. So in the question paper they mentioned like this. Question was this one. If it is plus Q, VA minus VB, positive or negative. If it is minus Q, VA minus VB, potential difference, positive or negative. That was the question. So depending upon your source charge, depending upon the nature of your source charge, the sign of VA and VB changes. Anyhow, potential that is inversely proportional to 1 by R. An electric field that is proportional to 1 by R square. So the graphs are similar. Okay, thank you.